Hey, welcome back. So in 1966, a guy called Peter Landin created one of the most influential but little known rules in computing. And the impact of that rule is still felt today, especially in languages such as Python. Today, we're going to talk about the offside rule. But before we talk about the importance of the offside rule, we actually need to understand the importance of indentation within the Python language. So to do that, we're going to create a very simple program. And that simple program is just going to take two numbers, and then it's going to tell us whether x is greater than y, whether it's less than y, or whether the two numbers are the same as each other. So to do that in Python, what we need to do is, first of all, create a Python file. So we're just going to call that maximum.py. So I'll just do touch maximum.py, and then I'm going to open that up in Visual Studio Code. And to make it super simple, I'm not going to read any values in from the console. What I'm going to do is just set the values of x and y manually. So I'm going to do x equals 20 and y equals 30. So two simple numbers. And again, if you watched my video on basic calculator, you will see that the language here, x equals 20, the way that Python does assignment comes from basic calculator. So the influence there is very, very strong, which of course is a C-style like syntax anyway. Now to determine the output here, what we need to do is use an if statement. So in Python it has the if, elif, else type syntax, which again originates back from languages such as Algol 68, but we'll get into that in a second because I'll talk about where those influences come from. So to do that, the first check I need to do is see if x is greater than y. So as you can kind of see there, it's going to print out x is greater than y. And then the first thing I'm going to say there, and this is really important within the Python syntax, so you see there's no parentheses on the if statement. Again, that's an influence that's coming from the old language ABC. And then you see I've got this print, x is greater than y, and that print statement is again being influenced by basic calculator, etc. So I talked about that in the previous video there. Now, if I come into here, the next thing that I'm going to do is I need to do an else if, because I've got another condition to check. I can't just do an else, because if I do an else, then it's just going to basically say x is less than y, but then of course it could be equal to. So the else if that I want to do, or elif, is going to be to see if x is equal to y. So you can kind of see the C-style syntax there for the comparison. X double equals y, and then this nice semicolon, and then it's going to say print x is equal to y. So elif, as I said, that comes back to Algol sort of 68 type structure. That's where that was introduced. And then actually, if I bring that forward a bit, elif was used by Stephen Bourne when he came up with bourne shell, which again was 1979. And again, that would have had a massive influence on Guido van Rossum when he was actually creating Python. So, that elif structure, I think, is going to be directly influenced by bourne shell, and then of course from Algol 68 there. But of course, Guido came from this ABC programming language. He actually coded in that for quite a while just before creating Python. And again, the influence there is ABC comes back to the folks that were involved in that actually were super involved in the Algol specifications. But again, I'm not going to talk about ABC in this video. We're going to do that in another video later on. So you can kind of see this influence of the language happening there. So the last thing I want to be able to say is, well, if it's not equal to y, then essentially x is going to be less than y. So we'll just put that there. X is less than y. So that is our basic if-else statement. And then we'll talk about the indentation in a second. So if I just type Python maximum.py, you're going to see it comes back with x is less than y. And the reason it's going to say x is less than y, you can see x is 20, y is 30, and then it's going to say x is less than y because that condition is not satisfied, this condition is not satisfied, and then it's going to drop down into that condition here. So the first thing we really need to get into here is we're talking about indentation, is that this is highly readable, right? And that was one of the tenets of Python that Guido was actually talking about when he came up with this, right? Is he wanted it to be a super readable language. And you look at it, and therefore indentation and the readability was going to be as important as it would be when you're reading something like a book. So if you look at that, if x is less than y, you've got the indentation here, kind of looks beautiful. Now, the second thing that you kind of want to point out here, and this is the important part of the Python language, is that indentation actually defines the scope. So when I look here, you see print x is greater than y. If I were to just copy this statement here, and put that in at the same level, and I could do the same here. Put this at the same level, and then put this here, and put that at the same level. And if I save that, now what I'm going to do is I'm going to get the same result outputted twice. And the reason is this sits within the same scope. It's not like something like C or, or even kind of basic calculator. It's not like it needs this sort of bracketing here, some sort of to define block scope. The scope is defined by the indentation. And that's one of the differences of style. So this is where indentation is actually defined in the code structure, as opposed to something like C or C++, where they have a kind of free form style. So therefore, the white space is not important. What is actually important is the code block structures defined by the curly brackets. And that is the big difference there. Indentation defines the scope. And we can kind of see that as well. So if I actually just take that print statement and bring it back a bit, you see I'm going to get a bunch of errors there because this print has moved outside of the scope of this if statement. So technically this print is at the same level as the if. So you can kind of see the red squigglies on the elif at that point. And the reason I'm getting the red squigglies there is it makes no sense from a language syntactically for to have an if, then have a print, and then be following an elif. Technically, what I would need for this program to work is I would need that if to become rather than being an elif, it needs to become an if. So actually, if you think about it, this elif structure is actually preventing major issues within the code, right? Because it's actually protecting us from syntactical issues because you can't have an elif sitting stranded on its own. And now if I run that same piece of code again, Python maximum py, you're now seeing I'm getting x is greater than y and then 2x is less than y's, right? And the reason is that if we look at this, if x is greater than y, you're going to see x isn't greater than y in this case because it's 20. But that print is now outside of this block. Yeah. So this is going to execute regardless. No matter what happens, that is going to execute. And you see that on the screen there, which is x is greater than y. And then it's going to do the comparison. If x is equal to y, then it's going to do print x is equal to y twice, which of course they're not, so it's going to skip that, and then eventually it's going to skip down into this else blocks, and then it's going to say print is less than y twice, which is what happens here. So if you think about it for a second, that elif is actually doing a lot of protection for us, that if, elif, else. If I were actually to follow a more modern kind of style to programming, and you see this a lot, which is the if, and not using the else's or elifs at all, if I follow that style, there is a risk that I might miss a piece of code, get an unreachable code detection issue, and end up with the equivalent of a GoTo fail. So it'll execute a piece of code that I don't want necessarily to be executed. But even then, even if I don't follow that if, elif, else structure there, you can see that Python is helping me out. If we just look at the code here, I can look down this and I see if x is greater than y, I can see the code block of indentation, but that print, because it's is sitting over here, the indentation's following the code structure, I can't get into any trouble really. I can visually see the code execution structure, and that's one of the key things about Python here, is that visual readability allows me to where I can see the code. Whereas in a language like C or even basic calculator, which I showed in one of my previous videos, with that C style syntax, that's not necessarily obvious. So what I could do if I want to is I could repeat what we did on the previous video with basic calculator, and we can create this maximum dot, I'll put it in a text file, but we'll create the same maximum function, but we're going to create it in basic calculator. And again, you're going to see the familiarity between Python and basic calculator as I write this out. X equals to 20, y equals to 30. And of course, there's a difference in the way if statements are represented because they're not coming from basic calculator, they're coming from more of a kind of bourne shell algol 68 influence. But if we just do if x is greater than y, and then we put print x is greater than y. And then I'll put the else if. Again, basic calculator doesn't follow elif, but it does follow else if, which is kind of close enough. X equals y, and then we'll print out print x is equal to y, and then we'll put in the else print x is less than y. So you can kind of see the influence between basic calculator and Python. I covered that in my other video. But now if I kind of come back into my terminal, and if we run BC for basic calculator, and I run maximum.txt, you can see it's kind of come back with x is less than y. But now if I make the same issues that we have with basic calculator, so if I put that print, let's put that kind of print x is greater than y twice in here, and if we save that, you're going to see when we get this, we're going to get a parse error bad token. So the reason we get the bad token issue is the same reason as we did with Python, which is you can't have an else if dangling on its own independent of the print. But again, if I come back to a kind of more modern style there, this visually looks as if that print statement should be part of the if x and y, but because indentation isn't formal code structure in basic calculator or any C-like language such as C, then technically the scope of this is over here. So if I now run this, you're going to see it's coming back with if x is less than y and x is less than y twice there. So now if I make x and y equal to each other, it's all going to go a little bit crazy. So if I just run that piece of code again, so I'll type in bc maximum.text, and you're going to see it comes back with x is greater than y and x is equal to y. And the reason is, if you look at this, x is 30 and 30. If x is greater than y, that's not true, so it's not going to execute this piece, but it is going to execute this one, because it's placed over here. There's no code block. If I wanted to fix that in BC, I could fix that in the exact same way as I could fix any C-style program. All I would need to do is run that again, and you can see x is equal to y. But because I'm not using my code block structure there, because the scope is not associated with the structure of the program, then this basically doesn't work. And then trying to find this issue becomes really difficult, because syntactically it looks okay, visually it looks okay, but the scope here is actually more like this. So of course there's multiple issues going on with this, which tends to be solved with modern compiler tools and things like linting, etc., and formatting, which allows you to be able to see the visual structure that you want. But actually from a language perspective, whether it's basic calculator C or whatever, that because there's no correlation between the program structure and the indentation, then you can't visually look at this and see what's going on. And that's the difference that Python has from an indentation perspective. From as far as Python is concerned, indentation defines that code structure and blocks and scopes. And that is the major differentiator of that language. Now, if I bring that back to the kind of craziness scales where things go really wrong, actually, if we go back to 2014, there was a famous bug from Apple where essentially opened up a whole exposure for man-in-the-middle attacks for iPhones, and really it came down to, I think it was something to do with the SSL certificates or something like that. I can't remember off the top of my head, but actually there is a piece of code that is in question there, and you can see that from this code there is that kind of modern style of if without any else's or any else ifs, and then you got this kind of go to fail, and there's probably a whole thing that we could get into about not doing go to fails for a start. If you look at that there, you can kind of see where the issue is. It's right at this go to fail, right? Which is, although this is a piece of C code, you're seeing that exact issue there where you haven't got the brackets because the brackets are optional. The go to fail is there. They look as if they should be part of the same code structure, but actually the go to fail, the second go to fail is running in that block there. And that's cause a major issue with Apple. So it's really kind of easy to do. Now, in this particular case, if they had had some decent unreachable code detection in their compilers and their build process, they would have picked that up. So that's one of the things that Python solves, is by having the indentation and the code structure being one and the same in the scopes, then that means that when you look at code, you understand what it's actually doing. So I think now you get the importance of indentation and how it is absolutely fundamental and one of the defining characteristics of the Python language. Now, if we look at the history of that, you will see that actually where that indentation comes from and all of the style behind that actually comes from the language ABC. And I think that is the direct influence, because Guido worked on that for quite a while. But ABC took that influence from much earlier, which it came from Peter Landin. And actually, interestingly enough, as I said earlier, the guys that worked on ABC actually were involved in the algol specification. And guess what? Who worked on the algol specification? Peter Landin. So Peter Landin is probably an incredible guy, and is probably something that I could spend much longer in these videos. He is actually the guy that created the first abstract machine for lambda calculus. Yeah, he's that important. So he actually is also the guy that defined the term closures. Yes, so if you are working in any language today where you're dealing with closures, any functional language, then that's really down to Peter Landin. So, whether you're in JavaScript, whether you're in any functional programming language, the impact he's had with, creating the first abstract machine for lambda calculus, defining what closures was, he has influenced almost everything in that sense. Of course, outside of computing, he was somebody who was actually a huge activist in the space of gay rights, for example. And of course, I think that starts to help sort of spell out the diversity that we've had in computing. So again, when we look at people like the impact that Alan Turing's had, absolutely incredible guy. And in fact, I think the Bodleian Library run an annual lecture in his name. I think he died in sort of 2009, 2010. And ever since 2010, they've been running an annual lecture. I'm really going to turn up at one point because he sounds like an incredible guy. So where did the offside rule come from? Well, actually, Peter Landin came up with this. I think it was in 1966. And it was in his paper on the next 700 programming languages. So in that paper, he created a new abstract language or family of language, which was called IceWim, which stands for If You See What I Mean. And again, we could probably spend a long time on this, but really this was all about kind of how to define languages in terms of languages. And again, this was one of the key things that sort of pushed forward things like lambda calculus. Although this language never got implemented, the impact that it had was absolutely huge. And again, it influenced these languages like Scheme, and then of course has influenced languages like ABC. So again, this is a hugely influential paper in the area of kind of functional programming. But from his perspective, the offside rule is almost a side note in this paper. So if we just search for offside rule, here we are, 1966. Indentation used to indicate program structure. A physical IceWim can be defined in terms of an unspecified parameter, a subset of phrase categories, instances which are restricted in layout by the following rule called the offside rule. And it was a little bit of a play on the old soccer ball offside rule. The southeast quadrant, it contains the phrase's first symbol, must contain the entire phrase except possibly for bracketed subsegments. Now we just bring this up a little bit further. The rule has three important features based on vertical alignment, not character width, and hence is equally appropriate in handwritten typeset or type text. So he's kind of saying this isn't like about computer screens or whatever. This is vertical alignment. Again, think of that Python program, straight down. You can look at the indentation in the code structure straight from there and understand the syntax from there. Its use is not obligatory and it can be mixed freely with more conventional alternatives like punctuation. Also, it's incorporated in IceWim in a systematic way that admits of alternatives without changing other features or languages that can be applied to other languages. So he's really sort of pushing here that indentation is as important and defines the code structure and is separating it away from kind of freestyle languages like C's, which obviously wasn't out at this point, but the languages before that like Algol 60. And there we go. Everybody talks about the indentation of Python and how it comes from the ABC programming language. But if we go a little bit further back in time, it comes from this little tiny rule that Peter Landin mentioned as almost a kind of side point in his paper, The Next 700 Programming Languages. So Peter Landin came up with this in 1966, and therefore the impact that that has had, whether it's on languages such as Scheme or Haskell, or even modern day languages like Python, or even modern configuration type languages such as YAML, where indentation is defined in the structure as well. That all comes back from Peter Landin's paper in 1966. So anyway, the offside rule, it's just not a soccer ball thing only, and hope you enjoyed this video, and I'll catch you on the next one.